Today, the Isaac Newton Telescope sits proudly at the Roque de los Muchachos Observatory on the island of La Palma, a modern, robotic instrument operating in some of the best observing conditions in the world. But for the INT, conditions weren't always so ideal. The INT was constructed in the 1960s at Hurst Monceau Estate in East Sus, at the time the site of the Royal Observatory, Greenwich. It was inaugurated by Queen Elizabeth II on the 1st of December 1967 and subsequently achieved first light. During its tenure at Hurst Monceau, the INT was responsible for an incredible discovery. Guided by astronomers Paul Merdin and Louise Webster, observations of the binary star system Cygnus X1 revealed that one of the stellar companions was in fact a black hole, the first confirmed detection of one. However, unforgiving English weather resulted in the INT's move to its current home in 1981, where it continues to operate today amongst the Isaac Newton group of telescopes, helping astronomers uncover the mysteries of the cosmos. A commemorative pin created by Brighton-based artist Mark Charlton to mark 50 years since the inauguration of the INT. This year, on the 1st of December 2017, Hurst Monceau is celebrating the 50th anniversary of this formidable instrument with an evening detailing the INT's working history and the discoveries it has made over the decades. The event will include an exhibition from Brighton-based artist Mark Charlton, exploring a futuristic vision of space exploration from the perspective of the 1950s. Dr. Paul Merdin, who helped discover the first black hole using the INT, will give a talk on the history of the telescope. We spoke to Dr. Merdin to find out what it was like working with the INT in its heyday, and how under his guidance it made one of the discoveries of the century. How did you end up working at Hurst Monceau and with the INT? I first went to Hurst Monceau and the observatory as a summer student. The Royal Observatory ran summer courses there every year for about 10 undergraduates, featuring lectures in the morning and project work during the afternoon. For an undergraduate, this was very attractive, and was an interesting job. Hurst Monceau was magical. We got to sleep in the castle and tour the grounds. We also got a bit of an allowance and free board, which for an undergraduate was a big plus. At the end of the course, I was talking with the Astronomer Royal and he asked what my plans were once I finished reading maths at Oxford University. I said I thought I might become a school teacher, but he said no, I want you to come and work with us. So it turned out that 6-week course was actually a job interview. A year later I finished university and went to work at Hurst Monceau, in about 1962. The INT was being discussed, but wasn't there yet. The kind of astronomy that was going on at Hurst Monceau wasn't really astrophysical, which is what I was interested in. It was more about astrometry, which relates to the positions of the stars. I'd only stayed at Hurst Monceau for about a year, before moving to the US to work in astrophysics. About 7 years later I was at a conference and met some people from the Royal Observatory, who asked whether or not I would come back, which I did. I worked on correlating optical observations of stars with work in other wave bands, particularly in X-ray. Amongst others, I used the Isaac Newton telescope and the 36-inch at Hurst Monceau. This included looking at the star that was identified with the X-ray source Cygnus X1. It was there that I and Louise Webster discovered that Cygnus X1 was a binary star, and that one of those stars was a black hole. This was the first coherent story about the existence of a black hole in our galaxy. The Queen visits the INT for its inauguration, accompanied by then Astronomer Royal Richard Woolley, the 1st of December 1967. Credit Science Projects Limited. The INT moved to La Palma because of the poor English weather, but it can't have been that bad if you were able to make such a discovery. I think it was actually the rather poor observing conditions that made it possible for us to discover that this star was a black hole. The star itself is not a particularly faint one, it's actually about 9 magnitude. For a telescope the size of the Isaac Newton to study a 9 mag star in somewhere like California, for example, that would be regarded as a bit of a waste. But for us the sky conditions weren't that good, and it provided an opportunity for us to study something that other people were turning their backs on. The INT wasn't a very big telescope. There were arrangements for being suspended underneath the Cassegrain focus sitting in a chair, but it was terribly cramped. It was like being shoehorned into a fighter plane's cockpit, I imagine. There was a claustrophobic feeling when you were operating it. In addition, it was not really in the right place to do the sort of observing that people had the ambitions for it to do. It was supposed to be run for the benefit of university astronomers, but the chances of completing a program of work in a short trip with the INT were not that good. On the other hand, if you were a resident at the site and could take advantage of such good weather as turned up, as I was, then you could get work done. In the case of the discovery of the black hole in Cygnus X1, one of the key things that was needed was consistent access to the telescope over a fairly long period of time because the binary period was 5.5 days. So you had to be there for considerably longer than a week, best if you could be there for 2 or 3 months or even longer. This meant that the telescope was neither wonderful for university astronomers, nor was it great for the on-site astronomers because they didn't get consistent access to it. You had to be an opportunist. Fortunately, I was able to exploit the opportunities that did turn up, but I think it did diminish its usefulness and the potential for it to make great discoveries. What sort of work did you do on the INT? I was often on a roster for a few days a month supporting visitors who were using the telescope. I helped them through the process, telling them how to operate the equipment, discussing aspects of their program at the beginning of their run, and how I thought they should go about it. Being there, I could see what they were doing, and if they were getting frustrated in the equipment wasn't working as well as it might, I could discuss problems with the engineering support staff. I competed, just as they did, for access to the telescope for other programs. So if I wanted to do something specific, I put in applications. Where I did get a free ride, however, was if a piece of equipment was being built and needed to be tested. It would be put on the telescope and the engineers would work on it, typically up until midnight. But then they'd pack up and go off to bed, leaving the telescope idle. Except of course at wasn't idle, because I would be in there like a rabbit inspecting the aluminum-coated surface of the 98-inch mirror of the Isaac Newton telescope. How did you feel about the INT's move to La Palma? At the time I supported it scientifically, because it was the right thing to do. Going to a good site where there were better opportunities was a good thing. Speaking as a member of a scientific organization, however, I didn't like the idea because it was removing a facility from my access and my control, or at least distancing it somewhat. Of course, it was fought bitterly by the administrators, but I was just a research fellow and so couldn't really influence that decision. You did eventually follow it to La Palma, however. I did partly as a result of the discovery of the black hole. I consolidated my scientific reputation and I was moved from being a research fellow to a permanent employee. I was lucky enough to be chosen as one of the first members of staff at the Anglo-Australian Observatory, which hadn't even been commissioned when I first went there. That took me into the realms of being a scientific support worker and running telescopes and delivering them for university astronomers. When my 3-year term came to an end, I had proven that I had the experience to work on the establishment of the observatory in La Palma. So I was brought into the team of people who were managing the transfer of the INT and also building the William Herschel telescope. A 15-minute exposure of M33, the Triangulum Galaxy, captured by the INT during its time at Hearst Moncho. Are your memories of the INT fun? To tell you the truth, no, I found it frustrating to work with. It was difficult to operate and get in and out of. The weather was constantly changing, and if it was cloudy, it might stay like that for the rest of the night, or for half an hour. I found all this very frustrating. So no, I don't remember the time at Hearst Moncho being as enjoyable as going to La Palma and using the telescope there, where if you start off with clear skies you more or less know you're going to get clear skies for the rest of the time and can accomplish great scientific things. My memories of it are very mixed indeed. Ultimately, the INT story has had a happy ending, though. Absolutely. The fact that it's productively used by astronomers from the whole world and that it has made great discoveries is a testament to that. The very first paper that came out of the Isaac Newton telescope was by Michael Penston. It was about the changing nature of one of the so-called active galaxies, a Seyfert galaxy. He had taken a spectral analysis of it at Hearst Moncho and then the telescope was dismantled and shipped out to La Palma and re-erected. Michael was one of the first people to use it. The first thing he did was to take another spectral of the same object and he found that the galaxy had changed its nature. It had changed from one kind of Seyfert galaxy to another. That was a big clue regarding how a Seyfert galaxy could change from one thing to another. The Isaac Newton telescope made good discoveries, and it is still making them, as far as I know. Image of Dr. Paul Merdin courtesy of Stephen Armishaw. Image of astronomer at the controls of the Isaac Newton telescope courtesy of Cambridge University Library. Carousel image of the Isaac Newton telescope at La Palma from www.worldtraveler.org.